This video is going to give us a chance to take an extra day to look at the more efficient factoring of trinomials, and it's going to try to help out anyone who needs something a little more concrete to go on to help them remember the strategy. So again, there's the objective, and let's see what we have. We're going to first start off by going back, and we're going to look at the area model for multiplying. And the idea was that if you thought of x plus 1 and x plus 2 as two lengths, x plus 1 in this direction, x plus 2 in that direction, then the product would be the area of the rectangle that it kind of carves out. And we use that as an idea to try to get across to people that we should expect 4 terms when we now learn FOIL or we double distribute or something like that. For the purposes of this later part of this video, we're going to look at this distance of 2 as two ones. So the product is going to be an x squared, a 1 times x, which is right here. And instead of this being a 2x, which still works fine for multiplication, I need you to think about it as two x's, an x here and an x here. And this 2, which was 1 times 2 in our previous videos, think of that as two single ones. And we'll see why. Because as we reverse the process, we're not going to know the factors. We're not going to know the side lengths, but we're going to know the product. We're going to know the trinomial. So this idea of the product being made up of 4 pieces, an x squared, a 2x from that, an x from that, and 2 1s from that, and therefore being equivalent to this trinomial, that's going to continue. But the process is going to be, let's take a look at the trinomial and try to learn how to factor it. So we're going to have to look at it as an x squared, 3 of these things called x's, and 2 of these singles that are going to make a rectangle, and then we can figure out what those length and width of that rectangle are once we've created it. This is just a representation to help people if they like it. If you don't like this representation, if at the end of this video you feel more confused than when you started it, you can really go after the symbolic approach. But I know sometimes people don't like looking at symbols, they need something else behind it. So this is what we're going to do. We're going to look at a trinomial in a second. It's going to be made up of a certain number of x squareds, a certain number of x's, and a certain number of 1s. And then we're going to try to configure those pieces into a rectangle. And if we've done that, then we've factored the trinomial. So here's the trinomial, and here's the visualization of it. Well, that's going to be a grid we're going to use. Here's the visualization of it. It's got an x squared in it. It's got 11 copies of x. It's got 18 copies of 1. And we're going to try to start put this into this grid. And if we can grid it out so all these pieces are used and it makes a perfect filled in rectangle, then we'll be able to go back and find, well, the length here is this and the width here is that. That must be the factors. So if we went at it kind of blindly, ignoring this efficient strategy we learned in the last video, we would put an x squared there maybe, and we're starting to create a side length of x plus something, we don't know what yet, and x plus something in this direction, we don't know what yet. And we could then start to use these x's to fill out a rectangle. For example, we could put one there. So we've now used an x squared and an x. Haven't used the entire trinomial yet. We haven't built the whole rectangle yet. We don't know the factors. The factors are certainly not x plus 1 times x, because this area doesn't represent the entire polynomial. So if you choose to try to take those remaining x's and stack them this way, we haven't quite filled out a rectangle yet, but that's okay. We've got this space to fill in, we've got 1s to use it. And if we use all of these 1s, exactly that many 1s to fill this in, and there's no 1s left over here, then we're going to know that the factored expression, the factored form of this is x plus 1 in this direction times x plus 10 in this direction. This length would be x plus 10, this would be x plus 1, and if all of these fill that in, then the product would be the trinomial. Let's see how many of these we need. We need that many. We didn't use them all. So we can now tell that this didn't work. We didn't represent the entire trinomial that was over here as a rectangle by going x plus 1 in one direction as one factor and x plus 10 in the other. Well, here's another possibility. Instead of trying to figure out how to use those x's and to stack them and then fill in the rectangle, why don't we instead do something that looks more like our efficient strategy, which is start with the 18 and think about the factor pairs of 18. This is a 3 times 6 version of 18. And yes, it guarantees to use all the pieces, all the 1s that we have in this trinomial. And what it does is it now makes a grid where we have to fill in with the x's. So you might already know that the 6 x's that you're going to need to fill out this part and the 3 x's you need here, it's not going to be all those. But now everyone's on board with that because this 9 x's The 9 that came about by having 6 slots here and 3 slots here, that was only 9x's, not 11. So it's all starting to come together that if we look at the factor pair of this thing, you can't just be satisfied with I found two numbers that multiply to 18. You have to think they also have to add to 11, or else we aren't representing the polynomial. So let's think of another rectangle where we could have used taken these 18 ones and made it into a rectangle. Now we can go with a 2 by 9. 2 times 9 is definitely 18, and that's why the rectangle has 18 ones in it. And better yet, it gives you 9 slots here and 2 slots here to fill in x's, and that's going to be the 11 x's all spent. So the entire polynomial, all the pieces of the polynomial are now mapping out a nice little rectangle. So this dimension is an x plus 9, and this dimension is an x plus 2, and that tells you how we could have factored this thing. So the whole purpose of this video is to give you another leg to stand on when you think, what's this plan again, and why does it work? That when I think of the factor pairs of 18, and I have to find the factor pair that adds to 11, why is that working? It's because it makes this rectangle, which allows you to see one binomial times another binomial equals the entire trinomial. So today's problem set is not going to have anything to do with this visual. It's just there. This visual is just there to kind of give you an extra look at it. And today's work is just to give you some more time practicing. So if you're having a hard time with it, definitely reach out. Let me know. It's a skill that takes some time to develop. And that's what I'm giving you today. Thanks.